Hey everybody, we are back and today we are talking about analyzing box plots. Now, I gotta put a disclaimer at the beginning. If you don't know what a box plot is, or you haven't watched an introduction or been given an introduction on box plots, this is not the video for you. This is for the people who have already learned the basic vocabulary and kind of already know the parts of a box plot. All right, because we're going to be looking at it and answering questions and not really talking a lot about the vocab. So here's my box plot. It says the box plot below shows the number of free throws made by a team during practice on 17 days. So we can say for sure somebody made 17 free throws, or the team one day made 17 free throws, and then another day they made 70, and then there's a bunch of stuff in between. Okay, let's look at some questions. First question. What is the greatest number of free throws made during one practice session? Well, I already kind of gave this one away, but our greatest is going to be our upper extreme, and that's 70. The most that was made by the team in one practice session was 70 free throws. Okay, the next question says, what is the range? And if you remember, the range means you take the biggest number, which we already know is 70, and you subtract the smallest number. And the smallest number here is 18. I think I said it was 17 on the other page, but it's actually 18. Because it lines up right there. That's 18, promise. And if you do 70 minus 18, you get 52. So the range is 52. The next question says, what is the interquartile range? And I love interquartile range, especially when they give you a graph, because if they give you a graph, that's the easiest way to do it. Interquartile range is just talking about the range of the box. So the left side of the box is 35. The right side of the box is 55. All we have to do is subtract those two numbers to get our answer. So the interquartile range is 20. I love it when they give me a graph. It makes it so much easier. All right, I got two more questions about this same graph, and these are both percents. So I will give you a quick recap. If you remember, each section of a box plot is worth 25% of the data. So the left whisker is 25%, the right whisker is 25%, the left part of the box is 25%, and the right side of the box is 25%. And it doesn't matter if the sections are bigger or smaller, it's just talking about how spread out the data is, but I promise it's 25% of the data. So, on what percent of days did the team make more than 45 free throws? So 45 is right there. More than is going to be this way. So this section of the box is 25. This whisker is 25. So that's 50% of the days. And if you're not sure where I got 50 from, I just did 25 plus 25. The last question for this graph says, on what percent of days did the team make less than 18 free throws? Well, 18 was down here. Less would mean I'm going that way. There's nothing. No part of the graph is down there. So on 0% of the days, did they make less than 18 free throws? So those are the kind of questions you could expect to see if you're given a box plot. But what about if you're given two box plots? Okay, so let's talk about comparing. So here I have two box plots. The box plots below show the time it took 16 students in two different gym classes to run 100 meters. So somebody in Miss Jones's class ran 100 meters in 15 seconds, but the fastest person in Mr. Strader's class ran it in 16 seconds. Okay, so you can kind of see what's going on here. Let's see what the questions are. First question, which box plot has a greater median? Well, the median is just this line in the middle of the graph. So the median for Miss Jones's class is 21, And the median for Mr. Strader's class is 23. So which box plot has a greater median? Mr. Strader. His class had a greater median. All right. Second question. What is the difference between the interquartile ranges of the box plots? Okay, love this. Remember, we just talked about interquartile ranges and how they're not so bad to do if you are given the picture. So, for Miss Jones's class, our interquartile range is 6. It goes from 24 down to 18. So that's 6 for Jones's class. And then for Strader's class, we're at 27 and 20, which means our interquartile range is 7 for Strader's class. So what is the difference between the interquartile ranges? Well, difference means subtract, and you may think, I've already done enough subtracting, but no, we got to do one more. We got to take these two numbers that we got, and we got to subtract them. So 7 minus 6, the difference between the interquartile ranges is 1. And that is your final answer. I'm going to highlight it because we did a bunch of work over there. Okay. Let's see what else we've got to do with these two box plots. Select all statements that are true. So that leads me to believe that there's going to be more than one that's true, but let's go through each one and figure it out. The first one says 50% of both classes ran 100 meters in less than 18 seconds. So 18 is right here. So let's extend that line. I know that this whisker is 25%, but did 50% run it in less than 18 seconds? No, and definitely not in Mr. Strader's class because that's not even a whole whisker. So this one is false. B says the upper extreme of Mr. Strader's class is higher than the upper extreme of Miss Jones's class. So the upper extreme in Mr. Strader's is 30, and the upper extreme in Miss Jones's is 28. So is Mr. Strader's higher than Miss Jones's? Yes. So that one is true. C says the range of Mr. Strader's class is greater than the range of Mrs. Jones's class. Well, let's figure that out. So Strader is at 30 and 16. So I'm going to write 30 minus 16, which is 14. And then I'm going to look at Miss Jones's. And Miss Jones's is at 28 and 15. So 28 minus 15 is 13. So the range of Mr. Strader's is greater than the range of Miss Jones's. So that one is true. That leaves me with one last one. Let's see if this one is true. Both box plots have the same lower extreme. Well, the lower extreme for Jones is 15, and the lower extreme for Strader is 16. So that one is false. And that's pretty much everything you need to know about analyzing and comparing box plots. Of course, the people who make tests can always dream up new ways to ask you questions, but if you can answer these, you can probably tackle anything that they're going to give you or dream up. Alrighty, see you next time.